All right, everybody should have 5.3 pulled up. All right, I can assure you guys, and I'm always up front with you, I can assure you 5.3 and 5.4 are much more manageable than 5.2. All right, some of you didn't think 5.2 is that bad. That's fine, but this is a lot better because this is, we're solving. It's all stuff that you're familiar with, okay? Again, your 5.3 WebAssign, I want you to just change it into a PDF and just use that as your problems. Submit the PDF because entering on WebAssign is kind of gross. I'll show you why in a second. But let's review for a minute. If I am talking about an ordered pair on the unit circle, I have an X value and a Y value, correct? Okay, so we have our 6 trig functions. We have sine, cosine, tangent, and then what are the reciprocals? Cosecant, secant, and cotangent, right? So in regards to an ordered pair on the unit circle, what is the sine? It's the y value. Very good. Sine is your y value. So what is your cosecant? No, what's the cosecant? 1 over y. Okay, good. What is cosine? X value. Good. What is secant? 1 over x. Perfect. And then what's our tangent? Y over x. So what's cotangent? X over y. All right, perfect. You guys are going to need that. So on your next test, you'll be given all the identities because you're going to have to simplify and verify. You will be given a unit circle, and you'll be given the formulas for 5.4. But you need to know this, which we already do, which is perfect, okay? How do we think when we're talking about trig stuff? How did I tell you guys to think? Algebraically, it's exactly what we're going to do. We are solving these equations. If this equation said 2x minus 1 equals 0, what would you guys do? Add 1 to both sides and divide by 2. That is exactly what we're going to do. But the one thing that's a little different is you have a trig function here. Just like we did when we had our logs, remember I told you guys to isolate the log or the exponential, keep it together. You want to get that sine of x by itself. So algebraically, the way that we would do that is we would add 1, which is what you guys just told me, right? So you have 2 times the sine of x equals 1. Divide by 2. So you're left with sine x equals 1/2. And now you're like, okay, well, what does that mean? Well, what did we just review? Sine is what value? The y. So what you're going to do, guys, is you are going to go to the unit circle. You're going to have your unit circle with you. And you want to find all the y values that are 1/2. So if I go to my unit circle, first of all, where are y values positive? Above or below the x-axis? Above. So tell me where the y values are positive 1/2. What is it? Okay, let's talk in radians. 5 pi over 6 and 5 pi over 6. So your answer here would be x equals pi over 6 and 5 pi over 6. So what you're doing is you're solving the equation algebraically like you would. Then you're going to use the unit circle to identify which angles that you're looking at. Now, guys, the unit circle is a pattern. You'll start to see things being redundant, being repeated. You'll start to notice different things. But what do you notice about the denominators of your answer? They're both the same, all right? You should not be getting random answers from the unit circle when you're looking for specific values because there is a pattern to the unit circle. Now, sometimes you're given parameters, like in the next question where it says between 0 and 2 pi, that means 1 trip around the unit circle. Sometimes they don't give you, so that's why we're not using WebAssign as our answer, because the way that you would answer this on WebAssign would be pi over 6 plus 2k pi. Meaning, if I was at pi over 6, right, you guys told me it's 30 degrees. Well, if I went 390, I'd be back at the same spot, right? a coterminal. Then if I go again, and then again, so if they don't give you a parameter of like 0 to 2 pi, that this is supposed to be in your answer. But we're going to do everything just one trip around the unit circle, so you don't have to worry about adding that to your answer. But that's just the reason why. No, we're not going to at all. No, we're not going to just go back and forth. We're going to just focus on just this part. All right, so again, we're going to think how? Algebraically. So see this interval right here? Don't worry about it. You guys are going to have to worry. Everything's going to be just one trip around, 0 to 2 pi. So I'm going to rewrite this. I have sine x plus the square root of 2 equals negative sine x. Now, if you guys have trouble visualizing this, rewrite it algebraically. This says x plus the square root of 2 equals negative x. If you were going to solve this, you'd get x's on one side, square root of 2 on the other side, right? Do you notice how they're both the same trig function? So it doesn't matter how you do this. I'm just going to subtract the sine of x from both sides. What's sine x minus sine x? It cancels. So I have the square root of 2 equals, what's negative x plus negative x, or negative x minus x? Negative 2, right? So negative 2 sine x. Now, we're thinking algebraically. Here's my trig function. How do I get sine of x by itself? Divide by negative 2. So you have sine x equals negative square root of 2 over 2. Now, that's not my final answer. What does that tell me? Where do I look on my unit circle? Y values. And I look for where the y values are what? Negative square root of 2 over 2. So go over to your unit circle, which you will have on your test. Where are my y values? Negative square root of 2 over 2. 7 pi over 4 and 5 pi over 4. Again, what do you notice about the denominators? They're the same. Good. So your answer would be x equals 5 pi over 4 and 7 pi over 4. So my last period said, what if I wrote 7 pi first? That's fine. Just as long as you got them both. If you want to write x equals and x equals, that's fine too. So you're thinking algebraically. You are just solving a basic algebra equation, and then whichever trig function is in your answer is what values you're looking for on the unit circle. Everybody with me? Yeah. Okay, good. All right, scooting along. Come on. Let's do 3 and 4. All right, how's this one a tad bit different? It's tangent and it's squared, okay? Now, again, let's think algebraically. If I said 3x squared minus 1 equals 0, what would you do? Add 1 to both sides. Divide by 3, and then take the square root. All right, that's exactly what we're going to do. I'm going to add 1 to both sides. So I have 3 tangent squared x equals 1. We're going to divide by 3. So I have tangent squared x equals 1 over 3. And then what did Max say to do? Take the square root. When you guys take the square root, what goes in front of your answer? Okay, so tangent x equals plus minus square root of 1/3. Is that all right? Okay, so let's simplify. What's the square root of 1? 1 over the square root of 3. Can I leave it like that? No, so I have to do what? I got to rationalize. So you're looking on the unit circle where tangent of x is positive or negative, square root of 3 over 3. Now, we have to think about this for a second, guys. What is tangent? Y over x. So you have to find the ordered pairs that when you put the y over the x, you get square root of 3 over 3. All right, that's what we're looking for. Now, a couple things you can do. You can A, just do the algebra. Or you can B, recognize. What did I tell you at the very beginning about the unit circle? It's all patterns. Look at the first quadrant of my unit circle. What do you notice about the x value and the y values? X and y are both what? They're both positive. Good. They're both positive, x and y. Now, let's look at the ordered pairs. Everything is what? Over what? Over 2. Good. Do you notice how we talk about denominators, right, being the same? Look at pi over 6 and look at 5 pi over 6. Is that the same ordered pair? Yeah, what's the only thing that's different? The sign. All right, look at pi over 6 and look at 7 pi over 6. Same ordered pair? The numbers are the same, but the signs are what? Different. Look at 11 pi over 6. Same numbers, different what? Signs. Everything around the first quadrant, everything is mirror image all the way around. It's just the signs are different. So if you know what all the ordered pairs in quadrant 1 will give you for tangent, you know what they all are all the way around. So you don't have to memorize this. It's just a good thing to know. What is the tangent when x is 1 and y is 0? Tangent is y over x, right? So 0 over 1, which is 0. So what is the tangent, guys, at pi? 0. It's the same thing. So let's go up to pi over 2. If I take my y value and put it over x, my y value over x is what? Undefined. So at pi over 2, my tangent is undefined. Well, what's the tangent at 3 pi over 2? Undefined. Same thing. Now, again, you guys could just work this out algebraically, or you could just be like, oh, wait, that makes sense. What about pi over 4? What's the tangent at pi over 4? What's anything divided by itself? 1, okay. So what's the tangent then, guys, at 3 pi over 4? -1. What's the tangent at 5 pi over 4? +1. What's the tangent at 7 pi over 4? -1. What are the only two options that could possibly give me a tangent of root 3 over 3? It's either pi over 3 or pi over 6, depending upon the denominator, depending upon which x value is first, which y value is first. So if we were to work this out, this is my x, and this is my y. Would you guys agree if I took square root of 3 over 2 divided by 1/2 is the same as times 2 over 1, right? So the tangent at that ordered pair is the square root of 3. So if I asked you what the tangent was at 2 pi over 3, you would tell me it's what? What's the tangent at pi over 3? What did we just figure out? Okay, the tangent at pi over 3 is square root of 3. So at 2 pi over 3, what is it, Max? Negative. Okay, good. At 4 pi over 3, it's positive square root of 3. At 5 pi over 3, it's negative, right? It's the same thing all the way around. So here, in this case, my x value, my y value, I have 1/2 times, I would flip this over, it becomes 2 over square root of 3. So this would be root 3 over 3. So at pi over 6, when my x value is root 3 over 2, my tangent is root 3 over 3. So all the way around, at 5 pi over 6, it's negative root 3 over 3. At 7 pi over 6, it's positive root 3 over 3. At 11 pi over 6, it's negative. Now, if you guys memorize that, great. If you don't, no big deal. Just know that you have to find tangents, you put y over x. Cotangents, x over y. So going back to the question, I wanted to know all the places where my tangent is positive and negative square root of 3 over 3. So where would the first one be? Which ordered pair gives me square root of 3 over 3? Pi over 6. So I have x equals pi over 6. I want the positive and the negative root 3 over 3. So where else? 5 pi over 6. 7 pi over 6. And 11 pi over 6. Again, what do you notice about the denominators? They're the same. All right, there is an order to everything on the unit circle. Yeah. Yeah, that's why, because it's plus or minus. Yeah.
Did you get 3 over 3 and pi over 6?
3 over 3?
Pi over 6.
Say it again?
Oh, wait, never mind. I got
I didn't divide it. I wrote it out as key change flip to save space. All right, here we go. Let's move along. Just look at this problem. Let's talk about it. Let's look at it. I have cotangent here, and I got a cotangent here, and then I have a cosine squared here. So let's talk about this problem. What do you guys notice? Okay, there's two. Good. One of them is squared. Okay, so algebraically, if we were looking at this, this would be like x y squared equals 2x. If you have something that is squared and something that is not, generally that's going to become a factoring problem. So before you try to solve anything, if I have something squared and something not, we should get everything where? To the same side. So let's just algebraically move everything. So I have cotangent x times cosine squared x. If I move this over, do you guys agree this becomes minus 2 cotangent x equals 0? If I moved this over, this would be xy squared minus 2x equals 0. Now, what would you tell me in blue? What would you say you could do with my x's there? If I was going to solve this, I could take out an x, right? They both have an x. You could do the exact same thing here. What do they both have in common? They both have a cotangent. So if you bring that cotangent out in front, divide out a cotangent here, divide out a cotangent here. Cotangents cancel. You guys are left with cosine squared. Cotangent cancels. Minus 2 equals 0. Now, if that said cosine squared x minus 1, what could you change it to? What's cosine squared minus 1 the same as? What's 1 minus cosine squared the same as? What's 1 minus cosine squared the same as? 1 minus cosine squared is the same as sine, right? So you could change that. If it was a 1, you could change it to negative sign. I'm just saying, we're going to use our identities in a minute.
Oh, we are?
Yeah, but very basic, very basic. Now, when you factor, right, if I factored this, I had x times y squared minus 2 equals 0, then you would set each of them equal to what? 0 and solve, okay? Same thing here. I'm going to set each of these equal to 0 and solve. So I have cotangent of x equals 0. Well, what does that tell me? Cotangent's what over what? X over y. So you're going to look on the unit circle where when you take the x value, put it over the y, you get 0. Right, over here. How would I solve this? What would I do? Add the 2 to both sides. Perfect. So you have cosine squared x equals 2. Now what? Take the square root. So cosine x equals, what goes in front of your square root? Plus or minus square root of 2. What is cosine? X values, right? So guys, where on the unit circle are the x values in any ordered pair the square root of 2? Do you see any? No. So then that's not going to work because we're only talking about places on the unit circle. How would you have to find that? You'd have to use the calculator. Hit cosine square root of 2. We need to get some wacko decimal. But we're not using calculators. We're only finding things on the unit circle. So that's not an option here. The only thing we can actually find is where when I take my x value and put it over the y, I get 0. So where could that possibly happen? It could only possibly happen on our quadrant angles, right? Any other ordered pair combination, you're not going to get 0. So if you need to think about it, then think about it. This is my x, this is my y. If I put x over y, do I get 0? No. Up here, if I put x over y, do I get 0? Yes, because it's cotangent. So if pi over 2 works, what else is going to work? 3 pi over 2. So x equals pi over 2 and 3 pi over 2. What do you notice about the denominators? They're the same. So much of all the stuff that we've learned in chapter 4, we're now bringing into chapter 5 and we're solving. Questions? All right, 2 more, and then we're going to stop. All right, you guys had this exact question on your review. It just didn't say equals what? It didn't say equals 0. All right, look, they gave you this interval 0 to 2 pi. All of them are going to be 0 to 2 pi, so don't worry about that. But if I'm thinking algebraically here, I notice I have a trig function that's squared, and I have one that's not. But both of them happen to be what? They're both signed. They're both the same. That means, guys, this is just a basic factoring problem. This says 2x squared minus x minus 1 equals 0. I would say 2 times negative 1 is negative 2. So if I'm going to factor this, what are the factors of negative 2 that multiply to give me negative 2 but add to give me a negative 1? Factors of negative 2 that multiply to give me negative 2 but add to give me negative 1. Negative 2, positive 1, good. What's going to go in the front of each of my parentheses? Sine, so I have sine x here, sine x here. And my a term is not 1, so what do I do with it? I'm going to divide both factors by 2. So here I have sine x minus 1, and here I have 2 sine x plus 1 equals 0. Now that I have fully factored, what do I do with each parenthesis? Set it equal to? So sine x minus 1 equals 0. 2 sine x plus 1 equals 0. Yep.
How did you get from the plus 1 over 2 to get down to just a plus 1?
2 divided by 2.
1.
Give me the 1. And then this doesn't divide pretty, so this becomes your coefficient.
Oh, okay.
So now, guys, we're going to add 1 to both sides. Agreed? So sine x equals 1. What is that telling me? Where is that telling me to look? Y values. That equal what? 1. All right, over here, I'm going to subtract 1 from both sides. So 2 sine of x equals negative 1. Divide by 2. Sine x equals negative 1/2. Where is that telling me to look? Where y values are negative 1. So in this case, we're looking for 2 different y values. No big deal. So where on my unit circle are the y values positive 1? Pi over 2. It's the only place. So you have x equals pi over 2. That would go here. And then I'm looking for where my y values are negative 1/2, which would be where? 11 pi over 6 and? So x equals 7 pi, whoops, not times 6, over 6, and 11 pi over 6. And that goes here. Sure. All right, same kind of problem. There's just a little difference. What is that difference? I have a sine and I have a cosine. So that's like saying 2x squared, right? If I'm thinking algebraically, this is like saying 2x squared plus 3y minus 3 equals 0. You guys can't factor that like it is. But if you converted everything to be the same, then you could. This is where our identities are going to come in. All right, I'm going to give you a trick here, a little hint. When you have 2 trig functions, one of them is squared, the other one's not. You always want to convert to the middle one. You want to convert to the function that is not squared, because you'll be able to use a Pythagorean identity to fix that. So if I want to take sine squared, I want to convert it into cosines. I want to convert to the middle one. What's another way that I could write sine squared in terms of cosine? 1 what? 1 minus cosine squared. Perfect. All right, now you will have your identities with you. But we're rewriting sine squared into 1 minus cosine because we want our trig function to be the same throughout your whole problem. Now that we just did that, this just becomes an algebra problem. What do you think I do with that 2 out in front? Okay, let's distribute it. So I have 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. All right, perfect. Now I have 2 trig functions. They are the same. One is squared, one's not. If this was replaced, if cosines were replaced with x's.
Can you move it?
Absolutely. Can we combine like terms? I have a positive 2 and a negative 3. What does that give you? Good, negative 1. Don't apologize. Good job. So I have negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. Now, if some of you are still a little like, ooh, okay, rewrite this algebraically. Negative 2x squared plus 3x minus 1 equals 0. Would I have you factor like that? Do I think that's a great way to factor it, leading with a negative? No. What would you guys do? Divide everything by negative 1, right? Do the same thing here. Get that negative 1 out. So I'm going to bring my negative 1 out in front. So I have 2 cosine squared x minus 3 cosine x plus 1 equals 0. So now this says 2x squared minus 3x plus 1 equals 0. Do we know how to factor that? Yeah. Yep.
You have to put the negative 1.
Once you take it out, you can leave it. I'm just showing every last step. So 2 times 1. What are the factors? Caitlin said, do I have to keep writing that negative 1? No, you don't have to. I'm just writing it so you guys see it didn't just disappear. What are the factors of 2 that will multiply to give me 2, but add to give me a negative 3? Minus 2 minus 1. Perfect. What is the trig function that goes in the front? Cosine, cosine. Perfect. Last thing, because my a term is not 1, what do? Divide both of these. Perfect. Now, my negative 1 did not go anywhere. We factored it out, so I have negative 1. 2 divided by 2 is going to give me 1, so cosine x minus 1 times, that doesn't divide pretty, so 2 cosine x minus 1 equals 0. Now, at this point, guys, what do you do with each piece? You set it equal to 0. So when I say negative 1 equals 0, is that ever true? No. That's why Caitlin's saying you don't have to, once you factor out that negative, you don't even have to worry about it anymore. But I just wanted to show you it didn't just disappear. It just doesn't mathematically work out. So you're left with cosine x equals positive 1. Do you guys understand why it's positive 1? I said equal to 0, moved it over. Here you have cosine x equals positive 1/2. Set equal to 0, move the 1 over, divide by 2. And what is cosine? What are the values that I'm looking for cosine? X values. Both x values. So I'm going to look on my unit circle where x value or values is just positive 1. Where is that? Where is it? Where is x 1? At 0, okay. You could say x equals 0. What's another way you could write that? 2 pi, yep. 0 and 2 pi are the exact same spot, so either one is fine. And then where are my x values? Positive 1/2. Say it again. Pi over 3 and 5 pi over 3. Yep. No, you're fine. I was just looking. X equals 5 pi over 3 and pi over 3. Again, what do you notice about those two denominators? They're the same. That's good. All right, so the last 3 examples I will do tomorrow, but you guys are doing a great job. Just think algebraically. We're just solving equations. That's it. And make sure we know where to look on our unit circle. Yes, ma'am?
Can you go back to example 3, please?
Sure.